Okay, now we will see that induced voltage in a NC turn coil. uh, Actually this was asked in SSCJE 2021 question. Okay, we'll see that question. Okay, what is that question? It is given: in a DC machine, let phi be the flux per pole, omega m be the armature speed in radian per second, and NC be the number of coil turns in the armature, and P be the number of poles, and what will be the average coil EMF in that machine. We have to find out that average coil. We have to find that average coil across that NC turn coil. Here number of coil turns is there, no? Here this number of coil turns means number of turns only. Number of coil turns means number of turns only. Number of coil turns means number of turns. Okay, number of coil turns means number of turns. And here they have given that 4 options, this thing, and this option is correct. And how to get this option and how to solve such kind of question. Okay, how to solve such kind of question we will see. That is, first what it is given, we have to keep it in diagram. That is, first what it is given is nothing but, see, he said that let us take a 4-pole DC machine. Let us take a 4-pole DC machine. That is, we are going to have that 4 poles like this. And first you take that armature. Okay, first you take that armature like this. Like this, one circular armature is there. Okay, like this, one circular armature is there, and in that one slot is there. In that one slot is there. Okay, and in that one slot is there. Okay, in that one slot is there like this. This is one armature. Okay, this is that armature, and in that one slot is there. Now inside that slot there is a conductor A. Let us say there is a conductor A like this. This is that conductor A. Okay, and it was placed in that 4 number of poles. This armature is placed in 4 number of poles. Let us say this is north pole. Okay, and this is the south pole, and again it is C. This is north pole. Okay, and again you say this is an south pole. And from these poles we are going to have the flux. From these poles we are going to have that flux. How that flux is? From north pole to south pole. Like this, it is their flux, and it is completing its path like this. Okay, it is completing that path like this, and here also that is flux is there from north pole, and here also this flux is there from north pole, and here also that flux is there from north pole. Okay, and in this flux this conductor A is moving at a speed of, what to say, let us say this is an Nm. That speed of this armature or this conductor is nothing but Nm. That is Nm revolutions per minute, RPM. That is, it is moving at Nm. Okay, in the flux, the flux per pole is nothing but phi. It is having that flux per pole phi. And this conductor is there, no? This conductor can be represented as in the axial length. This conductor is there, no? That is this conductor. Okay, this is the conductor A, and across this conductor we are going to have an induced voltage. Let us say this conductor voltage and E conductor induced voltage, and this conductor can be modeled as an equivalent to a battery like this. This conductor, and this voltage is nothing but this thing, this conductor A. Okay, this is the conductor A, and it is modeled as an equivalent conductor. Because why there is an induced voltage across this conductor? Because whenever a conductor cuts the magnetic field, an EMF is induced according to the Faraday's laws of electromagnetic induction. That is why in this conductor we are going to have an induced voltage. Now if you see the 3D image of this thing, this armature is there, no? How it looks like? This armature is there, no? it is going to look like this. Okay, this armature is there like this, and it is in 3D view. It is having all this axial length. Okay, this is having this axial length like this. Okay, and that in that we are going to have one slot here like this. Okay, in that we are going to have that slot. Okay, and inside that slot we are going to have one conductor A. Inside that slot we are going to have one conductor A. This conductor A, it is there, it is running all the way like this. It is running all the way. This is that conductor. This conductor is there, no, this is represented as like this. This conductor here, this is there, no, it is represented as like this. This is the axial length, and this is the conductor. Okay, let us, we will start this derivation now. This is that basic thing about all these things. Okay, we will start that derivation. That is, we are going to have, let us say it is an 4-pole machine. Even though it is an 4-pole machine, let us say that we are going to have, let P be number of poles in that machine. Number of poles in that machine. Number of poles in the machine. Then phi is nothing but, it is the flux per pole in Weber. It is the flux per pole in Weber. Okay, it is the flux per pole in Weber. It is the flux per pole Weber. That is nothing but, it is the number of flux lines, number of flux lines from one pole, number of flux from one pole, that is either from north pole or south pole. That is, whatever this number of flux lines coming from this one north pole or one south pole, or one north pole or south pole, is nothing but phi, number of flux lines. Because 1 Weber is equal to 10 power 8 Maxwell. 10 power 8 Maxwell, and 1 Maxwell is equal to 1 magnetic line of force. 1 magnetic line of force. That means in 1 Weber we are going to, how many have? We are going to have 10 power 8 magnetic 10 power 8 magnetic lines of force. 10 power 8 magnetic lines of force. Okay, we are going to have 10 power 8 magnetic lines of forces in 1 Weber. Okay, that is the thing. Now what we are going to say, that is, when conductor A completes, when conductor A completes one revolution, when conductor A completes one revolution for 4-pole machine, the conductor cuts 4-5 flux. Because why? Since flux per pole is 5. That is, see, this under this one pole we are going to get 1-5 flux. That is, when armature completes one revolution like this, it is first it is cutting 5 flux, and another under south pole another 5, and another north pole another 5, and another south pole another 5. So that means for one revolution, one complete revolution, it is going to cut 4-5 flux. 4-5 flux. It is going to cut 4-5 flux. Okay, that is it is having one pole, means one pole it is cutting 5 flux. Okay, so now 4 pole means it is going to cut 4 5 flux. That means here we are going to multiply 4 on both sides. Okay, in order to get this equation, we are going to multiply 4 on both sides like that. Okay, now that is the thing, that is the meaning of that thing. Similarly, for p-pole machine, as conductor moves or completes one revolution, then conductor cuts 5p flux. Okay, 5p flux. That is how it is. For one pole, the conductor is cutting how much flux? 5. So now for p pole, the conductor is going to cut p into 5. That is here multiplying p on both sides, that is here we have shown only 4 poles. That is, if there were p number of poles, then when conductor moves one revolution, then it is going to cut this conductor is going to see p poles for one revolution. So for one pole we are going to have 5. So for p poles we are going to have 5 into p. Okay, that is the thing, that is the meaning of this thing, okay. Now let conductor makes nm revolutions per minute, that is nrpm, that is nm rpm, that is in 1 minute we are going to have n revolutions made by that conductor. Okay, this conductor is there, no, this conductor in 1 minute it is going to rotate nm revolutions it is making. In 1 minute it is going to make nm revolutions it is making. That is the meaning of that thing. Okay, nm revolutions. So but 1 minute is nothing but how much? We are going to have 60 seconds, which is nothing but in 60 seconds it is going to make nm revolutions. Okay, now in 1 second it is going to make nm by 60 revolutions, that is divide by 60 on both sides, that is the conductor is taking, that is the conductor in 1 second going to make nm by 60 revolutions. Okay, that is this conductor A is there, no, it is going to make nm by 60 revolutions in 1 second, and it is going to make nm revolutions in 1 minute. That is the meaning of this thing. Okay, that is the meaning of this thing. That is what is nothing but the conductor took 60 by nm that is the conductor took 60 by nm second to complete one revolution, to complete n revolution. That is now this equation is there, no? Now in this equation what we will do, we will multiply 60 by nm on both sides. That is 60 by nm second will be equal to 1 revolution. That is multiply by 60 by nm on both sides. That is in one revolution the conductor took 60 by nm seconds. Okay, to complete one revolution the conductor took 60 by nm seconds. That is, when conductor is moving at nm rpm, the conductor took how much? Nm by 60 by nm seconds to complete one revolution, to complete one complete revolution. Okay, now induced voltage across conductor, it is given by, that is E conductor, that is induced voltage across conductor. E conductor is nothing but d phi by dt. Okay, this thing you already know. This is Faraday's second law, Faraday's laws of electromagnetic induction second law, that d phi is nothing but flux cut by conductor in one revolution divided by, where dt is nothing but time for one revolution, time taken by conductor for one revolution. Okay, that is we already know that the flux cut by the conductor, that numerator term, the flux cut by conductor in one revolution is nothing but phi p. You have already derived phi p, and the time for one revolution by conductor is nothing but how much? It is nothing but 60 by nm. So now you can write it as n phi p nm divided by 60. That is whatever that conductor A is there, no, here like this. This is the conductor A. Across this conductor we are going to have an voltage E conductor. This voltage is nothing but phi p nm divided by 60. That is, this can be modeled as a simple battery like this. This voltage is nothing but E conductor. This E conductor value is nothing but this one. This is the meaning of that thing. That is what is that meaning is nothing but, whenever a conductor is moving with the nm rpm in a p pole machine, such that one pole is producing a flux of phi, then the induced voltage across that conductor is given by phi p nm by 60. Okay, that is the thing. Now say there is another slot. There is another slot. There is another slot. In that slot we have conductor B. And distance between those two slots, that is slot 1 and slot 2, is pole pitch, is nothing but pole pitch, which will be equal to 180 degrees electrical pole pitch. That is how it is going to have is nothing but that is in this way. That is, this is that armature, whatever you have seen previously. This is that armature. Okay, this is that slot 1, and there is another slot at 180 degrees. This is slot 2. Okay, and we are going to have that north pole, and here we are going to have that south pole, and here going again north pole, and here we are going to have again south pole. In that thing we are going to have this conductor A, and similarly we are going to have a conductor B, and these two conductors are connected in series. These two conductors are connected in series. That is, this is the distance between, the angular distance between. Okay, this angular distance is there, no? This angular distance is nothing but 180 degrees electrical. That is, these two are there. Now in that, now that is the angular distance. Okay, now similarly, okay, now similarly the induced voltage in conductor B, the induced voltage in conductor B will be, what? That conductor also is like this only, no? It is also there like this. That conductor B, it is also having that conductor B, and this conductor voltage also 5 p nm by 60. Why? Because conductor B moves in same flux pi and at same speed of nm revolutions per minute. That is nm revolutions per minute, and also it is moving in that same system what that conductor B is moving. Here also the number of poles are P only. Okay, that is the thing. Now these two conductors, conductors A and B are connected in series. Now conductor A and B are connected in series. That is, we are going to have conductor A like this, and we are going to have conductor B like this. Okay, and across this conductor we are going to have that voltage E conductor, and here also we are going to have that conductor voltage E conductor. Okay, now these two conductors are connected in series like this. Okay, now these two conductors are connected in series. This conductor A is under north pole and this conductor B is under south pole. This conductor is in slot 1. This conductor is under slot 2. Okay, now here we are going to get one voltage. This is nothing but EAB. Okay, now this EAB is nothing but EA plus EB, because write KVL equation here, plus E conductor and plus E conductor. Okay, that is, we are going to get 2 E conductor voltage KVL. Then how much you are going to get this voltage? 2 phi P nm divided by 60. That is this thing. Okay, now this system, whatever here we have got, this system is there, no, this system can be represented simply like this. Okay, okay, this is that thing, that is this plus minus, it is nothing but EAB. This is the voltage EAB, and this is conductor A, this is conductor B. It is under north pole, and it is conductor B under south pole. It is in slot 1 and it is in slot 2. This thing is represented like this. That is this EAB, which is equal to 25 Pnm by 60 induced voltage is induced, it is the induced voltage across one turn coil, or one turn or one coil. That is one turn coil or one coil, like that. This is that voltage, whatever that you have seen. Okay, now say okay, now okay, now say there were NC number of such turns in slot 1 and slot 2. Slot 1 and slot 2. That is, you can see, I will draw that diagram. That is, we are going to have armature like this. Okay, this is nothing but that slot 1, and this is nothing but that slot 2. Okay, then here we are going to have north pole, and then we are going to have here south pole. We are going to have again north pole, again we are going to have one south pole, such that there were NC turn coils like this. Okay, that is, we are going to have NC turn coils in that, and all these are moving at Nm RPM. All these are moving at Nm RPM. This is nothing but that slot 1, and this is nothing but that slot 2. Now what it was saying is that is all these NC turns. Okay, now all these NC turns connected in series, that is how they looks like, means this is the way they look like. These conductors, whatever these conductors we have there, no, in slot 1 and slot 2. Okay, this is another term. That is, they are connected like this, NC turns like that. Like that. Okay, that is this is under north pole and this is under south pole, and it is under slot 1 and it is nothing but slot 2, and across that each conductor we are going to have that E conductor voltage like this. Here E conductor, here also this E conductor, here E conductor, and here also we are going to have E conductor voltage. That is in full pitch coil, because one coil side is under north pole and another coil side is under south pole. Okay, so this is in coil, no, this is called as in one coil side and this is called as an another coil side. This is under north pole and this is under south pole. It is in full pitch coil, and across this thing we are going to have that En voltage. That is a voltage across that NC turn coil. Okay, NC turn coil. That is, this thing can be modeled as, this thing can be modeled as, this thing can be modeled as like this. This is one, this is another turn. Like this we are going to have NC turns. NC turns. Okay, NC turns like this. Okay, this is the first turn, this is the second turn, and this is an NC turn. Okay, and across this we are going to have that whatever we have got, no, that 5P Nm by 60. Here also 25P Nm by 60. That same voltage it is there, and these all are connected in series like this. Okay, and across this we are going to get that En. Okay, this voltage is there, no, this 25P voltage is there, no. This 25P voltage is nothing but this voltage only, EAB voltage, whatever we have got. This across one turn we have already derived, no, that voltage only, this voltage we have got here. Okay, now this in order to get this En voltage, you apply KVL in this loop like this. You apply KVL, that is adding this all these 25P Nm NC times. Okay, that is now write KVL. Okay, KVL, that is KVL, that is nothing but KVL. What it is giving? En is equal to, it was 25P Nm by 60 plus 25P Nm by 60. Okay, and plus so on, and plus 25P Nm by 60. Like that, how many terms? 2 NC terms. Okay, then now you are going to add how many? En is equal to, you'll get 25P Nm and divided by 60, and this is nothing but you are going to get NC. Okay, this is addition. Okay, but we already know that speed in radian per second, omega m is equal to 2 pi Nm by 60. This is the speed in radian per second. Radian per second. This is in RPM. From this thing you have got Nm is equal to 60 omega m divided by 2 pi. Okay, now substitute this thing to get that En. How much? 25P, okay, NC divided by 60. We are going to substitute that whatever that Nm is there, no, that nm 60 omega m divided by 2 pi. With this two you cancel, 60 and 60 you cancel. What we are going to get is nothing but 5 p nc omega m and pi. This is that voltage. Whatever this voltage is nothing but this voltage is nothing but this is across this turn coil. What? 5 p nc omega m and it is divided by pi, I think. Yes, what is it? 5 p nc omega m divided by pi. Okay, that is the thing. This is the voltage that is across that this nc turn coil. Okay, okay, whether we have got the same thing or not, we'll see. See, 5 omega m ncp divided by pi. This p also we have got 5 p nc omega m pi. Here I forgot to write that p. Okay, 5 p nc omega m p by pi. 1 2 3 4 5. Numerator 5 terms, denominator 1 term is there. One, 2, 3, 4. 5 omega m ncp. Five p nc omega m. Why we are going to get here? Phi p nc omega m and p. Okay, this is an for p pole machine, no? We have that phi p omega m and nc 1 2 3 4 by p. Phi omega m nc and p. Four terms. Why we have got here? Oh, I have written no another p no here, not required. Already p here it is there. That is the thing. Okay, only four terms. 5 p nc omega pi pi. This is correct. What we have got, the same equation we have got. Okay, thank you.